Alright, so today we're going to turn decimals into fractions, the opposite of what we did yesterday. When we turn decimals to fractions, the key is to remember place value. Key is to remember place value. So anything to the left of the decimal point, so like 1 point something or 2 point something, that's going to be the whole number in our mixed number. And then we look at everything after the decimal point, and we look to see where it ends at. So if the decimal part ends in the 10th place, we say it's that number over 10. If it ends in the hundredths place, we say it's that number over 100. And we continue to do this and so on. 1,000, 10 thousandths. And then we simplify if we need to. So we'll be using place value to figure out these questions. So what this second thing is saying, in other words, we have the whole number and then point, and then we'll look at the 10th place and the hundredths, thousandths, and so on. So there probably will be a lot of simplifying today. Because if you write something over 100 or 1,000, we got to simplify that down. And just assume that all of these numbers that we write as fractions need to be written in simplest form. Alright, so let's look at our first example then. So one thing that I would suggest is maybe don't say it out loud, like if you're taking a quiz or something, but just say to yourself, how would you say 0.65? It's 65 hundredths. Yes, 65 hundredths. So I'll even write 65 hundredths, which means you just do exactly what you just said. Put 65 over 100. Do we need to simplify 65 over 100? Yes, we do. Divide both of them by 5. 65 divided by 5 would be 13 over 20. Is that in simplest form? Yes. So 0.65 is 13 over 20. 0.65 is 13 over 20. Okay, so let's look at our second one. Negative 3.125. So what I would do is, wherever you're going to write your answer at, I would go ahead and put that negative 3. That's going to be the whole number. This will be a mixed number when you write it as a fraction. So negative 3, and then we've got to figure out what is the fraction part going to be in this mixed number. 0.125 would be 125 over 1,000. Yeah, and one way to know this is not going to be 125 over 100, because that's an improper fraction. So it's just going to be one step up. So 100 spot, one step up, would be over 1,000. Now we need to do some simplifying. What could we divide both 125 and 1,000 by? And don't try, if you don't get the biggest number, it's fine, AJ?
Wait, could it be 25?
You could divide by 25, yeah. If you don't think 25, you could always divide by 5. But yeah, you could actually divide this by 25. 125 divided by 25 is 5.
Over 40.
And then 1,000 divided by 25 would be 40, yes. Now we get 5 over 40. If you divided by 5, you would just do 2 of those steps instead of just 1 like we did.
Can't you still simplify?
We can still simplify, yeah. Divide this by 5 again. Which gets us 1 over 8. So now, put this 1/8 back up in our answer, because it needs to be -3 and 1/8. And that is our mixed number. Yes?
So whenever we have a whole number, we're just bringing it out of the problem.
Basically, yep. Yeah, if you have a whole number like what he said, we're just basically bringing this -3 out, and it's going to be a mixed number. We don't have to do anything with that -3 part. Any other questions? All right, what about 0.7 repeating? 0.7 repeating. So right now, that 7 is in what plot? What spot? The tenths. But is 7 over 10.7 repeating? No, okay. So what if we said it's 0.7 repeating? So it would be 0.77, right?
Yeah.
So let's say it was 77 over 100. Is that the same thing as 0.7 repeating?
Yeah. Yeah.
All I have to do is add another 7, and then add another 0, and now it's 777 over 1,000. But it's not the same thing. This is 0.777. That was 0.77. That's not the same thing. I could keep adding a 7. Why could I keep adding a 7? Because it's repeating, right? So if it's repeating, that's not going to work. Think back to what we said yesterday. If it's one number repeating, what is it going to be over? Remember? Over 9. Everybody remember what we said yesterday about that? We said if it's a number, the same number repeating, it's that number over 9. We said 7/9 is 0.7 repeating. 4 over 9 is 0.4 repeating. So in math, almost always there's some formula or some method to get the answer. When it comes to repeating decimals, you just have to remember this. And so this 0.7 repeating is actually going to be 7 over 9. And then I want you to also write, if it's the same number repeating, so if the same number is repeating, then it is that number over 9. So if the same number is repeating, it is that number over 9. And as 7th graders, you're probably only ever going to have to remember that for repeating fractions. The other repeating fractions, probably not going to have to memorize it. But you do need to remember this.
What about like the other ones that have like multiple ones repeating?
Like 0.16 repeating, or like the 0.54 repeating.
Yeah.
You should not have to remember that this year. You're not going to be asked those questions. So, if we had 0.2 repeating, what is that going to be? 2 over 9. What about 0.8 repeating? 8 over 9. What about 0.6 repeating? 6 over 9, but you can simplify, can't you? 6 over 9 simplifies to 2 over 3. That is why 2/3 and 1/3 are repeating, because it goes to actually 3 over 9 and 6 over 9. So last thing before we move on, what about 9 over 9?
It's 1.
But based off of what we said, shouldn't that be 0.9 repeating?
Whenever a numerator is the same number as the denominator as well.
Yeah, but based off this rule, shouldn't this be 0.9 repeating? Because it's 9 over 9, 0.9 repeating. Alright, before I confuse you much, it is the same thing as 1. 0.9 repeating is actually the same thing as 1. Because how many times is that 0.9 going to be written? Forever, infinity. So mathematically, it just rounds up to 1. Because 0.9 repeating, always going to be 0.9, so we just round that up to 1. Okay, so this one I just wanted to make you think a little bit. 9 over 9 is 1. Okay, 9 over 9 is 1. Alright, so remember that about the 9s. Anything, the same number repeating, it's that number over 9. So I want you all to go ahead and do the next 3. Do those next 3 on your own. I think you can get it. Alright, our first one here, 1.75. It's going to be 1 and something. So now we just focus on that 0.75. 0.75 is going to be 75 over 100. Okay. Someone tell me, what can we divide 75 and 100 by? Alex? We could divide them both by 25, yeah. Which is going to get us 3 over 4. You could have divided by 5 as well. Just do an extra divide by 5. So 1.75 would be 1 3/4. anytime you get 0.25 or 0.5 or 0.75, I always think of money, quarters. If you've got $1.75, you've got $1.75, or 3/4. Alright, so 1 3/4 for that one. Negative 3.875. So that negative 3 we can go ahead and write as our whole number and a mixed number. And then we've got to focus on that 0.875, which is going to be 875 over what? Over 1,000, yes. What could we divide 875 and 1,000 by, Charlie? What did you say? 25? All right. If we divide them by 25, that's going to get us 35 over 40. We agree with that? Okay. What can we divide 35 and 40 by here? By 5 again, which is going to be 7 over 8. That's simplified now. So negative 3.875 is negative 3 7/8. Negative 3 7/8. Okay, and our last one here, 2.3 repeating. So we know it's going to be 2 and something. So that 0.3 repeating, remember if it's repeating, the place value doesn't work. But 0.3 repeating is the same number repeating. So what is that going to be then? Use the rule that we talked about just a second ago. 0.3 repeating, same number repeating would be what? 1/3. So first let's use the rule we talked about a second ago. It's the same number repeating. It's going to be this number over 9, 3/9. But, Talon, what should you do with 3/9? Simplify it, divide both by 3. And so you're going to get 1/3. So 2.3 repeating would be 2 1/3. 2 1/3. As you start to do more of these, you're probably going to see a pattern with some of them that always have the same denominator. And so if you do that, and you always want to do the work, make sure that you're correct, but you start to see a pattern, that's going to help a lot. Alright, so we got a few problems to be working on regarding this topic.